Okay, this one's going to get a bit wild, so buckle up, buckle up, buckle up. What am I going to do? Well, I have to first appreciate that there is something difficult happening here. Okay. This is 0 over 0. Okay, the numerator is going to 1 minus 1, and the bottom is going to 0. Okay, so I have a problem. Now I have this formula. I know that cos x minus 1 over x, I know this is going to go to 0, but that's not going to really help me here because this guy can be factored like this, where I bring out the x here. Okay, trying to force this expression to appear. But I still have a problem, right? Because this guy is going to 1 over 0, and this is going to 0. So effectively, I still have 0 over 0 here. So I haven't really solved my problem by factoring like this. Okay, so that was a dead end. I have to do something else here. So, you're probably erasing all that and cursing me now, but such is life. What am I going to do? I'm going to do some fancy footwork here. I'm going to multiply the top and bottom in a way that uses the difference of squares formula. It's kind of like rationalizing the numerator. So I'm going to do this thing, where this is cos x, and my b is 1. So I'm going to try to exploit this difference of squares formula. So I'm going to take my original fraction and multiply top and bottom by, it's going to be cos x plus 1 over cos x plus 1. So this is a trick, I'd say, but it works out nicely, as we'll see. So I'm going to get cos squared x minus 1 on top. On the bottom, just like when I rationalize the numerator, I'm going to leave the denominator untouched. Now, I have to notice here that sine squared x plus cos squared x is equal to 1. So cos squared x minus 1 is sine squared x. Oops, with a minus, right? There's a minus on this guy, minus, right there. Don't forget that. So this is a memorized formula, and I solve for cos squared x minus 1. So my numerator can be replaced with negative sine squared x. My denominator remains the same. And I keep working here. Okay, so what can I do? I can try to make the expression sine x over x appear, because that goes to 1. So I'll do that. So I get, let's move this minus out front. And then I'll have sine x over x. And then I will have a sine x over something, and then I'm going to have 1 over cos x plus 1. Now, I think I made a typo somewhere. Where's my mistake here? Let's zoom out and find my mistake here. Ah. My mistake is the x squared got lost. So my x squared became just an x, which was erroneous. So sorry about that. Make these changes here. It should be x squared here, x squared here, x squared here. Okay, so sorry about that. Make all these changes. Now where was I? I have this expression, which I'm going to try to break up in order to make use of this limit. So it works out quite nicely. You get a minus coming out front, and then you're going to have sine x over x appearing twice. And then the last thing left over is this 1 over cos x plus 1. Now we're in business. Minus lim. Oops. Now I can do my limit, right? So I got the minus, and then I got the two things here and here that are both going to 1. And then this is a fraction with a 2 on the bottom. So I get negative a half. All right, so that's a fancy little trick there. Doesn't come up very often, but it does come up here and there. So the trick was to multiply top and bottom by cos x plus 1. Now what I want you to do now is to go back to this theorem. And as an exercise, this will be a bit tricky, but I want you to use the trick and part A, so this limit, to prove B. So use the trick, multiply this guy top and bottom by cos x plus 1, and then use this limit here to prove B. Okay, give it a try. Okay, here I go. I'll show you how it works out. Solution. So I do limit x goes to 0 of cos x minus 1 over x times cos x plus 1 over cos x plus 1, just like before. And then on top I get cos squared x minus 1. On the bottom I leave it alone. Just like before, the numerator becomes minus sine squared x. I get x cos x plus 1. Now I'm going to break this up just like I did last time. It's going to look a bit different though. The minus will come out front just like before. I'll have sine x over x. And then I'll have sine x over 1. Multiply, multiply, and then finally 1 over cos x plus 1. So my minus stays. This fraction goes to 1. This guy, it just goes to 0. And then this fraction goes to a half. And that's where my 0 comes from, as expected.